In this lesson, we'll examine a systematic technique for drawing conclusions about expressions involving even and odd numbers. To demonstrate this technique, let's see what conclusions we can draw about x and y if we're told that xy plus y is odd. Well, to begin, this expression involves two variables, x and y, and each variable can be either odd or even. So there are several different cases to consider. X and y can both be odd, or x can be even and y can be odd, and so on. Now each of these cases will cause our expression xy plus y to be either odd or even. To keep track of the different cases, we'll use a table, and for each case we'll determine whether the expression evaluates to be odd or even. So what are the possible cases here? Well, x and y can both be even, x can be even and y can be odd, x can be odd and y can be even, or both variables can be odd. So there are four different cases to consider. Now let's see what effect each case has on our expression xy plus y. So for the first case, we'll replace the x's and the y's with e to show that they are both even. To evaluate this, we'll apply our rules regarding even and odd numbers. So in this first case, we have an even number times an even number, which is even, and then to this we add an even number, which will result in an even number. So for the first case, where x and y are both even, the expression xy plus y evaluates to be even. For the next case, we'll plug in e's and o's for the even and odd numbers. When we apply our rules here, we see that the expression evaluates to be an odd number. We'll follow the same steps for the other two cases as well. So we now know the outcome for each of the four cases. Now we're told that the expression evaluates to be an odd number. When we examine our table, we see that there is only one case where the expression evaluates to be an odd number. In this particular case, x is even and y is odd. So we can conclude with certainty that x must be even and y must be odd. Now some students may find it cumbersome to plug e's and o's into the expression and then apply these rules for each case. So another strategy is to plug actual numbers into the expression. For example, if x and y are both even, we can replace both variables with 2's. When we do this, our expression evaluates to be 6, which is even. Now it doesn't matter which odd numbers and which even numbers you plug in. However, it's a good idea to use small numbers to make your calculations easier. So for odd numbers, plugging in a 1 will make calculations easy, and for even numbers, 2 is a good number to use. Now using a 0 for even numbers can make calculations even easier. However, the only drawback is that a 0 might get confused with an O, which represents odd numbers. The important point here is to use small values when plugging in numbers. Okay, for the next case, we'll plug a 2 in for the even number and a 1 for the odd number. When we do this, our expression evaluates to be 3, which is odd. We can continue this method for the other two cases, and when we do so, we see that our results in this table are the same as they were in the first table. Only one case results in our expression evaluating to be an odd number, so we can be certain that x is even and y is odd. Okay, let's try another one. Let's say that we're told that 6x minus 3y evaluates to be an odd number. If this is true, what conclusions can we draw about x and y? Well, we'll use the same strategy to examine the four possible cases. So for the first case, we'll plug in e's to represent even numbers, and then by applying our rules, we can see that the expression evaluates to be an even number. Following the same steps, we can test the other three cases as well. Alternatively, we can plug even and odd numbers into our expression and then evaluate them to get identical results. We've now tested all possible cases. Now we're told that the expression evaluates to be an odd number. When we examine either of our tables, we see that there are two cases in which the expression evaluates to be an odd number. So there are two possible conclusions we can draw. Either x is even and y is odd, or x and y are both odd. Either of these two cases can be true. Okay, as you can see, we now have a systematic technique for drawing conclusions about expressions involving even and odd numbers. So when you encounter a question involving even and odd numbers, consider creating a table to test the various cases. If you use a table, you can use E's and O's to represent even and odd numbers, and then apply the following rules. Or you can plug even and odd numbers into the expression, and then evaluate the expression. Finally, once you've tested each case, you can draw conclusions based on the various outcomes.